In this video, we're going to work through 3 more examples of drawing Lewis structures. And for these examples, I've tried to pick structures that are a little bit different and that we're going to have to think about how to apply our steps. So let's start with the polyatomic cation ammonium, or NH4 with a +1 charge. As always, the first thing I'm going to do is arrange these atoms in our structure. Nitrogen will be in the middle, and then the 4 hydrogens will be around the nitrogen. Next, I'm going to add up the valence electrons in this structure. Nitrogen has 5 valence electrons, and each hydrogen has 1 valence electron, which brings that total to 9. And I also have a +1 charge here, which means that I need to take away 1 electron from this total. And so that means that there will be 8 valence electrons in this structure for me to distribute. As always, I start distributing those electrons by bonding all of the atoms to the central atom. So I make 4 single bonds between each hydrogen and nitrogen. Each one of those bonds uses 2 electrons. That means that I've used all 8 of my electrons for this structure. Now we don't need to worry about this because a hydrogen is an exception to the octet rule and it fills with 2 electrons. So that means that hydrogen will only form a single bond as it's done here. So for ammonium, NH4 with a +1 charge, this is my completed structure. I don't need to do anything else. All right, up next is sulfur dioxide, SO2. We're going to do the same thing. We're going to arrange our atoms, so sulfur in the middle, oxygen on either side. Then I'm going to add up the valence electrons in this structure. Sulfur and oxygen are in the same group. That means they each bring 6 valence electrons for a total of 18 electrons in this structure. Start distributing my 18 electrons by adding a single bond between each oxygen and the sulfur. Each of those bonds uses 2 electrons. That means I've used 4 electrons out of my 18. I've got 14 electrons left. We start distributing those 14 electrons by completing the octet for each oxygen. So each oxygen is going to get 6 non-bonding electrons to bring it to a total of 8. Six non-bonding electrons on each oxygen uses 12 electrons out of my 14. That means I have 2 electrons remaining. These 2 electrons go to sulfur. So anytime we have remaining electrons after we've completed the octet, we pair those electrons on the central atom, or in this case, sulfur. The sulfur will also get a non-bonding pair of electrons. So we use those 2 electrons and that brings our total to 0. We have no electrons left. Even though we have no electrons left, our structure is still not complete. If we look at sulfur, we can see sulfur still is not filling its octet and only has 6 valence electrons. So we need to form a double bond. I don't have any electrons left to give it, so I'm going to repurpose a non-bonding pair of electrons on one of the oxygens. I'm going to take that non-bonding pair and we're going to drop it into a double bond. And when we do that, now those electrons are shared between sulfur and oxygen. The last structure we'll look at for this video is the sulfite anion, or SO3, the -2 charge. I'm going to start by arranging my atoms in the structure, so sulfur in the middle, oxygens spaced around it. Again, sulfur and oxygen are in the same group, so each of them is bringing 6 valence electrons. And then we also have the -2 charge on this anion, so that's 2 additional electrons added to our total. So all in all, we have 26 electrons to distribute in this structure. start distributing those 26 electrons by adding single bonds between each oxygen and the sulfur. Each of those bonds uses 2 electrons. So that means I've used 6 out of my total, and I have 20 electrons remaining. Next, I'll complete the octet for the oxygens. Each oxygen is going to get 6 non-bonding electrons to bring it up to a total of 8. So 6 electrons on each oxygen uses 18 electrons out of our total. 20 minus 18 is 2. So I have 2 electrons remaining. Just like we saw in our last example, anytime we have electrons left over here, we're going to pair those on the central atom. So these 2 electrons are going to go to sulfur. Sulfur is going to get a non-bonding pair. And when we add that non-bonding pair to sulfur, we've used all 26 of our electrons, and we have 0 electrons remaining. Now at this point, if we check our structure, we'll see that each oxygen has a completed octet, and sulfur also has a completed octet. So we are done. No double bond needed for the sulfite anion.